Three-dimensional geometry. The figure below represents a prism ABCDEFGH of length 6 centimeters. The section ADEH of the prism is a trapezium in which AD is equals to 11 centimeters, HE is equals to 8 centimeters, BG is equals to 5 centimeters, and angle ADE is equals to angle DEH, which is 90 degrees. The diagram is given there. Let's go to the first question, part A. Calculate correct one decimal place. 1. The angle between line DG and the plane ABCD. That is the angle between a line and a plane. Go to the other question, part 2. The angle between planes ABGH and ABCD. That is the angle between two planes. And the last question, calculate the volume of the prism. So those are the questions. Let's go to the first part, where you're supposed to calculate the angle between that line DG and the plane ABCD. You notice the plane ABCD is the base. So the first thing you're going to do is to identify that line, to draw that line DG. So we draw line DG. So line DG is there. So we need to get the angle between that line and the base, that is ABCD. Now to get the angle between a line and a plane, we do get the angle between the plane and the projection of that line. So in this case, we shall first begin by getting the projection of DG on the plane ABCD. So what is the projection or the shadow of DG on the plane ABCD? This point, I'd like you to look at this point. Point G will be projected straight, perpendicularly below. So it will be projected there. That is G. And therefore, this will guide you to know the projection of DG. D will be projected exactly where it is on that plane. So G will be projected on this point. We can name this point as maybe a letter that is not here, N. So G will be projected at N, that will be the shadow. Then D will be projected where it is on that plane. So therefore, the projection of DG on the plane ABCD is this particular line here. So that will be projection. And you notice that this one will form a right angle triangle at this point. And therefore, when you're getting now the angle between DG and the plane, we normally get the angle between that line, that is DG, and its projection on the plane ABCD. And which is that angle? The angle is here. This is the angle that we need to get. So this will be the angle. The angle between that line DG and its projection. Its projection is DN. So we need to get now that angle. Look at that triangle, the triangle formed. That is triangle NGD. Look at that triangle. We'll be able to get, let me see whether we'll be able to get any side here. So can we get DN? Yeah, we can get DN. Let's start by getting DN. And when you look at DN, we are going to consider this triangle, triangle NCD. When you consider that triangle, this side is 6, that is a CD is 6, and then we have CN. For us to get CN, we will need to add another line here. If we draw this line from this point, so from that point down, you'd notice that this line, which is here, this line is parallel to this and is also parallel to this, and this point from D to this point here, this is from this end, DA is 11. Let me start with the DA. DA is 11, and we have this particular line, EH. EH is 8, so also FG is 8, so therefore notice this, GF is equivalent to CN. Is very important. So this line here, FG, is equivalent to CN. So therefore, this line, this is 8, this is 8, and also this will be 8. I can name this point here as X. So also can add this. Also, this one is equivalent to DX. So GF is equivalent to CN is equivalent to DX. So that is 8. So if that is 8, and given that DA is 11, that means that this distance that is left here will be 3, and this one will be 3. So that we have the whole of DA being 11 and also CB being 11. Now having that, we have identified now that line on the length of CN. We can now get DN. Let's calculate DN. Now to get DN, we are going to consider this triangle here, triangle NCD. If you consider that triangle, it is right angled here. So you notice that DN will be the hypotenuse, and to get the hypotenuse, you simply need to get 8 squared plus 6 squared. And this will give the square root of, this is 64 plus that 6, 100, and this will give 10 centimeters. So we have a DN as 10 centimeters. What we need another side of that triangle G and D. And when I look at this triangle, simply look at this triangle here, triangle B and G. So when you look at this triangle here, you notice that this side is 3, this is 5. So we're going to use the Pythagoras the ratio here. This is 3:4 is to 5 is what you're going to use. So therefore, this is 3, this will be 4, the missing side will be 4, and then this one will be 5. Or you can simply use Pythagoras theorem to do that. So now, in that triangle, we have what we require now, because if I can just sketch it here, you notice we have that is N, then that is G, and that is D. So we have this side is 4, and then we have DN. We got DN as 10. We just calculated that, and therefore to get this angle, because this is the angle that we require, we simply need to use trigonometric ratios. And for this one, we shall use tangent is okay. So tangent of theta will be opposite, which is 4, adjacent, which is 10. So therefore, this will give theta being, you get the tan inverse of 4/10 is the same as 0.4. And this will give the angle as, correct one decimal place, this will be 21.8. 21.8 degrees. So that is how you work out the first part. Let's go to the second part. The angle between planes ABGH and ABCD. So allow me to clear these so that we can try to identify those planes. So the plane here is ABGH. ABGH, can see that. ABGH is this one. And then the base the angle between those two planes, the base. So you notice that the angle between those two planes is this angle that is here, or this angle. And since I had drawn a line here, there's a line I had drawn here. If you remember that from the previous part, there's that line I had drawn there. That line was perpendicular, and having obtained that that is 90 degrees, and we had also identified that this side is 3 and this one is 4, then that is same thing that will happen here. If you are to draw another triangle, that will be still 3, this will be 5, this will be 4. So either you can use either of these angles. This will give you the angles between those two planes. So we just need to take that triangle. So let me simply sketch it here. So this is the required angle. This is 5, this is 4, and this is 3 from the diagram here. So we can use any ratio here. We can decide to use, let me use a sine. Sine will be okay. You can use tangent. You can use any that you want. Cosine, me use sine. So sine of this angle, theta here, you can call it theta or alpha, and can do is equals to opposite, which is 4, divided by hypotenuse. So theta will be obtained by, get the sine inverse of both sides. So when you get the sine inverse of both sides, you get theta is equals to sine. You get this one will be sine inverse of 4 divided by 5. Using a calculator, this will give 53.1 degrees. So that is how you get the angle between those two planes. That was straightforward. We didn't have to do a lot of working because we had already calculated for that height. That is 4. Now let's go to the last part. And the last part is where you're supposed to calculate the volume of the prism. So this prism has a cross section of a trapezium. So the cross section here. So the cross section may indicate. So this is the cross section, the trapezium. And therefore, to get the volume of this prism, we'll simply get the area of the cross section. So it will be given by the area of the cross section multiplied by the length. So the cross section is trapezium. You know how to get the area of the trapezium. So to get the area of this trapezium, we'll get it by getting half. That is half times the sum of the two parallel sides, which is 11 and 8, and then the height is 4. The height is 4. So half times the sum of the two parallel sides, that is 11 plus 8. 11 plus 8, then the height is 4. So we get that. This will give, divide this one by 2, you get 2. This will be 38 centimeters squared. Then now we have the area of the cross section. Now we multiply by the length. The length is 6. This is the length. This is the length here. The length is 6 centimeters. So therefore, volume is equals to area of the cross section, which is 38 centimeters squared, times 6 centimeters. And this will give 228 centimeters cubed. And that is simply how you're supposed to solve that question.